All right. Hi, everyone. Thanks for coming to this space. Today, I'll be talking about data and AI processing at scale made easy using Daft. So, first of all, can I get a raise of hands if you've heard of Daft before? Okay, one, two, three. Okay, very little people. That's great. Okay, all of you are going to learn about Daft today and how it's going to work into your data and AI processing. Cool. Next slide. All right. What is data and AI processing? Specifically, I want to paint a picture, a frame of thinking of how I'm going to talk about data and AI processing today. And I'm going to think of it in terms of the applications of data and AI. What are some example applications of data and AI in the world? For example, we could have recommendation systems like Spotify, music recommender. When you click shuffle, that's a data and AI application. Search engines like Google, that's a data and AI application. And any kind of AI powered analyst, recruiter, accountant, you name it. And specifically, what do these applications have in common in terms of data and AI? They're going to require, a large amount of data. You're going to have to collect, analyze, and transform large amounts of information and store that somewhere. And you're going to need to apply an ML or AI model to extract valuable insights. For example, when you click shuffle in your Spotify for it to let you recommend new music, it has probably collected a lot of information about songs, about artists, about playlists, and it's going to use a trained AI model to recommend you the next song. So today, I'd like to actually build a data and AI application with Daft. So first of all, a bit about me. I am a software engineer here at Eventual. I build Daft. Daft is a distributed data engine. My primary focus is on query execution. I like making Daft queries run fast, run performantly, run reliably. Previously, I graduated from USC last year. I had a couple internships at companies like Stripe and Coinbase. And my personal interests, I really like to cook and I really like to eat. Last weekend, I did an in-house Korean barbecue. It was really nice. And I especially love to eat sushi. All right. I am a sucker for omakase, good sushi. And, you know, when the team at Eventual had an internal hackathon with an omakase prize on the line, naturally, I'm excited. I'm riled up. I have to win this thing. And so what we built was a data and AI application. It was an AI recruiter called Hamachi Recruiter, hence the picture of the fish. And this AI recruiter was able to answer questions like, who are the best Rust developers in data processing? Who are the best ML engineers who work on TensorFlow in the last 10 months who live in the Bay Area? All right. I wanted to build a search engine that had answers, had access to developers. And so, first of all, some context. Why did we even build this thing, right? Why did I make a website with a search bar with a fish on it, right? Eventual and Daft, we're an open source company. We want to find who the best open source developers are so we can work with them, so we can hire them. And if we go on GitHub and we search up who are the best open source developers, it kind of craps itself. It doesn't know what I'm talking about, right? It gives me zero results for users and gives me a bunch of results for code and repositories and issues. I don't care, right? I want to see the developers, right? If I do this, I have to look into all these repos that I know about. I have to scroll through the commits. I have to look at these repos, these contributors. I have to look at their code, look how good their code is, look what kinds of code are they committing. Do they actually have a meaningful impact to this project or not? And I kind of have to do like a manual code review on whether this guy is good or not. But what if we had an application that understands what I'm trying to do, right? What if I had an application that can understand, I want to find the best Rust developers in data processing, and it's going to give me exactly what I want, the best Rust developers in data processing. This application knows the developer's code, it's seen it, it's reviewed it. It can tell me how good this developer was to this project, how good of a coder they are, what languages they used, how many commits they did, and which repos they contributed to. Next. So how do we build this thing? Remember, I have an omakase dinner on the line. All right, I have 2 days to do this. This is my hackathon project. I don't have time to waste. There's two steps. One, we need data. We need developer data, lots of it, to populate our search engine. We need names, we need emails, we need repos, and we need their contributions, most importantly. Now we need to review these developers. We're going to do a code review on these developers somehow in 2 days to rank them so I know which developers are good or not. And so in 2 days, the best idea I had, and probably the idea that all of you are going to have is using my boy here, right? We're going to use an LLM to review our developers. And lastly, of course, we need to host the data on some website that's going to be queryable. And so these first 2 points, go back. Okay, go back. Yeah, these first 2 points, next, are exactly what we're going to be talking about today. We're going to break this up into 2 parts. First of all is the data part. How are we going to find these repositories? How are we going to extract all the contributors, all the developers, all their code? How are we going to store that? Second part, how are we going to run inference? How are we going to pass these developers and their commits through ChatGPT and get them out in 2 days so we can have our search engine? And can we use a single tool for both data and AI? My answer to you is yes. And that's exactly the tool I built. I built Daft. It's a Python data engine for data engineering, analytics, and AI. It is powered by Rust for snappy local execution. It's as fast as DuckDB, as fast as Polars on a single node, and it easily scales across a distributed cluster to something you might do with Spark extremely easily without changing a line of code. And you can try it with pip install Daft. Right. I'm going to call out 2 functionalities of Daft that I'm going to be talking about throughout the presentation, but here's a quick sneak peek. You can do all kinds of things with Daft. Most importantly, you can do traditional analytical operations like you might do with a database or a data frame API like pandas, like group bys, joins, and aggregates. And you can write arbitrary Python code in the form of UDFs. So today, the kind of things we'll be doing is we're writing code to parse logs. We're going to write code to run inference on our LLMs. And this is all going to be abstracted away around a data frame API. The next thing is when I scale this code up with Daft, it's going to be super easy. All I have to do is change a single line of code to point Daft to array cluster, and it's automatically going to parallelize all our code for me. Cool. Let's get down to business. Phase one is going to be data. We're going to find our repos and our contributors to build our data set for this application. Instinctively, the first thing I do as a Python developer, I'm going to use the GitHub API. I'm going to say, hey, I want this query. I want you to give me a list of repos ordered by stars that use Python. All right, pretty simple. But now we need to, sorry, what? Now we need to run, this query on multiple queries, right? Maybe I want to search repos for Rust, for JavaScript. I want to search across different project types, like ML frameworks, web frameworks, and then I want to persist those results in some file for later use. With Daft, I can put this custom GitHub API search code inside a function, put that function into Daft's data frame API, and it just works, right? We make the API request concurrently, and we write the results to a CSV file. Or I might choose a Parquet file. I might have a lot of data. I might want to store it efficiently in columnar format. Maybe I want to store it in S3 in cloud storage. Just write Parquet. Or maybe I'm feeling fancy today, right? Maybe I'm going to write to an iceberg table. With Daft, this is super possible. We can write to files and data catalogs locally and in the cloud. All right. During the hackathon, with this script, we collected a list of 15,000 repos. We had their names, their URLs, the description, and how many stars they had. Now, after we have these repos, we're going to extract the contributors, right? Remember, we're building a developer search engine, so we need to actually have names of people as well as their contributions. So I'll just use the GitHub API again, right? I'll just pass in the repo URL, let the GitHub API do its thing. Hey, GitHub API, give me the commits, give me the contributions, right? Unfortunately, it's not as simple as that. We had 15,000 repos, and who knows how many commits or contributors these repos had. I was getting bottlenecked really hard by GitHub. It's only letting me make 5,000 requests per hour, and there's no way I was going to get through 15,000 repos in 2 days for my hackathon. So here's what we did. Remember, Daft can run arbitrary Python code on our data frame. So we thought, you know what, let's just clone the repo. All right, we'll clone the repo. We'll do a git log on it. We get a whole list of all these logs and these commits from every single repo. We're going to write our own parsing code to extract all the commits, and then we're going to put that with Daft, and then we're going to export the results somewhere. So now I'm thinking, I have 15,000 repos. I'm going to clone them and I'm going to do string parsing on them. And then who knows how many commits I'm going to have. Can I really do this locally on like my laptop or my little MacBook and, try to win an Omakase prize in the next day? Probably not. So I'm working with Daft, right? Daft scales easily to a distributed cluster. I just need to change a single line of code to make Daft work on my laptop to a cluster of 4, 8, 20 nodes, you name it. So we spun this up. We looked at our dashboard. We got 4 nodes. CPU is going crazy. IO is going crazy. Everything's good. The Daft progress bar is cooking. The tasks are running. The RAID dashboard is going fine. And at the end of the day, we cloned all 15,000 repos. We extracted a total of 33 million commits, and we did it in 30 minutes. Oh, thank you. All right, next step. We have a master list of commits, right? But we want to group them by the contributor because we're doing code review on these contributors. Right now, we just have a list of commits. We need to group them. Again, with Daft, really simple. This is a classic group by operation, right? You might write this in SQL. You might write this on your Python data frame. You might use pandas for this. You can do it with Daft really easily. It's just group by the repo and the author email, and you aggregate all the other fields that you want. Pretty simple. Let's look at the sample of data. Let's check out Sammy. So Sammy is the founder of Daft, and these are his aggregate commits. And you'll notice that we have 3 founders at Daft. Did I mess this slide up? No, because turns out you can use multiple emails in GitHub, right? One single contributor can use multiple emails. And this is a classic problem where even though you think your script, your data workload is going fine, your data though isn't really fine, right? So what we did was just as most people do, you just dedupe it, right? You dedupe on the name, you collect all the emails, and then you're good. Now we had a list of 250,000 contributors together with all the commits they ever made across these repos in like, I don't know, hundreds of 100 like Parquet files living in cloud storage. And this was day one. This was day one of the hackathon. Next, we're going to go into phase 2 now. We're going to do code review on these contributors using AI. So let's start with the prompt. Um, we noticed that, and we thought it wouldn't be fair to us if we just gave the code and the commits to an LLM and let it, tell us how good this developer was. We wanted to instruct it. We wanted to give it a rubric, right? I want the LLM to evaluate this guy or girl the way I'm gonna do it. And so this is real code from our script. We literally said, go back. Think of Jeff Dean as being a 10 and a script kiddie being a 1. Yep. And then we're going to wrap this prompt in our LLM client. And as usual, put this entire Python function inside a Daft UDF and let Daft just handle everything for us. And you might be wondering, what are these 2 things, right? Daft works with rows and columns of data, and an LLM is just going to dump out, I don't know, text or whatever. So how do I get the LLM's output to match something that Daft expects? And here's a pro tip. If you're familiar with the library called Pydantic, you can actually create Pydantic data models and have LLMs conform their output to these models exactly the way you want it. And so we wanted 3 fields here. We wanted to know how good a developer was for their project, how impactful they were to their project, how good they are technically, and I want this LLM to give me a reason for why they scored it. And so with this Pydantic model, we can actually get our LLM to output exactly the fields that we want. using a library called instructor, all we do is we take this OpenAI client, we put it inside instructor, and we give instructor the Pydantic model that we wanted to use. And lastly, how do we get Daft to use the exact same Pydantic model? We use a library called Pydantic to PyArrow, which takes the Pydantic base model, converts it to a PyArrow schema, and then Daft takes that PyArrow schema and uses it as the Daft return type. In essence, we created a Pydantic model and we used it both to tell Daft what the output of this LLM is and tell the LLM to output in this exact format. And with that, we were able to create our full Python function that was going to do our code review for us. But here came the second problem that we faced. Again, rate limits. Unfortunately, we were on like the lowest tier of OpenAI. We made the account like the day of, and they have this thing where like if you don't use enough, they won't upgrade your tiers. So we were like, okay, you know what? Let's go. Let's just. We don't have time for this. All right, I don't have time for OpenAI's rate limits and upselling nonsense. All right, you know what? We're just gonna spin up our own deployment of GPUs, and that's exactly what we did. Right, next slide. We spun up our own deployment of GPUs using Fireworks AI, and now we have basically the resources we need to code review 250,000 contributors in time for hackathon. So there's a kind of a different problem now, right? Instead of being limited by OpenAI, now we want to maximize our resource usage because we have an on-demand deployment of GPUs. So how can we change this code, right, and make it super performant? And I'm going to tell you that the answer to making 50 to 80 requests per second on your GPU in like two lines of code. And it's called, next, async await. Really simple. We made our client async. We put this inside a UDF. We created our own async IO event loop, and we were able to get basically 5 to 6x improvements in throughput. Slide. Here's a quick comparison of the results that we had with synchronous requests versus asynchronous requests. If you're ever doing any kind of large-scale AI inference, I highly recommend you do it async because you're going to make concurrent requests and it's going to increase your throughput through the roof. And so our result, 250,000 reviewed contributors in 3 hours. And one thing I like to point out is that we actually ran this job overnight, and that's something that most of our users actually do, right? These large-scale inference jobs usually take hours, maybe even days, and it's really important that you have a tool that's going to be reliable, scalable for a use case. You probably don't want to be writing your own Python scripts to do this. That's going to take hours and days because that's not something reliable and that's not a good use of your money. Cool. And now here's a quick demo of what the platform looks like, right? We built this on the second day. You have a search bar. You can type in your query, like who's the best Python developer in blah, blah, blah. You can search for it, and it'll display you a list of results. And if you want to check out the website and the repo for yourself, the link is sashimifortalent.com. The code that I used to build all of this is on my GitHub, and you can find a blog post on how we built this on the Daft blog. So to recap, we had 2 phases here. Both we used Daft for. We took only 2 days. The data phase, finding the repo, extracting the commits. We cloned a bunch of repos manually. We parsed the Git logs, and we created a master data set of contributors. And in phase 2, we code reviewed every single developer using LLMs. So what are some learnings that we took away from this project? One, we recognize that we can actually make the inference experience on Daft a lot better. Next slide. Instead of actually making, spinning up our own Python event loop in the UDF, we can make the entire UDF async. This is going to improve performance and improve user experience. Next, we know that your UDFs and your inference requests are likely going to return a lot of data. In order to reduce your peak memory usage, it probably makes sense to yield those results, stream those results out as they come in. And lastly, of course, observability. We know that these jobs are likely taking hours and days, and it's going to be really important that you're going to be able to see exactly what's going on inside them. All right. Thank you. Thank you for listening. Yes, and please join our Slack if you haven't. And yeah, just want to call out that we are also hiring for a bunch of roles, engineering roles. If you want to work on Daft, if you want to do really large scale inference with Daft, please scan the QR code and or let us know. If you want to be part of hackathons where you can win omakase, please join us. Juni, yeah.
Thank you, thank you, thank you. Are there any questions for Colin? Any questions? Yes, right here.
Yeah, no worries. All the talks have been interesting. Yeah, Daft is very cool. USC Go Trojans, and also I saw that Jeff Dean mentioned. I think you might like searching up his coding partner. I don't know the full name, but initials are SG. Interestingly enough, one would code, the other one would read the code, and then they would switch. So if you like Jeff Dean, you might like that person's work as well. But anyways, about Daft, my question is, I saw a bunch of the UDFs and even your thoughts about asynchronous and streaming UDFs I haven't heard before. I'm really excited for. Are you thinking about bringing UDFs into SQL functions?
Yes. Yeah, we're actually working on it right now. So you'd be able to define UDF somewhere and then register it in some like registry of functions and then actually use those functions in SQL itself.
Very nice. Anybody else? Any other questions? Omakase or otherwise? No? Okay. Thank you, Colin. Appreciate it. That was awesome.